Hey guys, so we are going to talk about how to read a two-way table. So on your homework 9.1, let's just look at example 1 and part 2 on the bottom half of the first page. And let's look at this example. So if you see there's this two-way table, and on the left side we see it says both parents smoke, one parent smokes, neither parent smokes, total. And then across the top it says student smokes, student does not smoke, and total. So also I want you to notice that the bottom row are all totals, and the right column is all totals as well. That's important. So what does the table illustrate? So it illustrates the relationship between students who smoke, students who don't smoke, and whether or not their parents smoke. Maybe both parents, one parent, or neither parents. So we're going to use this table to answer some of the questions below. Okay, so A, what percentage of students smoke that have one parent that smokes? Okay, so I need to look at students that smoke, which is this column, and have one parent that smokes, which is this row, and I'm going to look at where they overlap. So if you notice, they overlap right here. So it says 416 students that smoke have one parent that smokes. 416 students that smoke have one parent that smokes. So what are we going to put that out of? We are going to put that out of the total down here, 5375. And it asks us to write it as a percentage, so I'm going to convert this to a decimal. It's approximately 0.077395. And then if I multiply that by 100, it will give me a percentage, approximately 7.74%. Okay, let's try B. What is the probability that a student does not smoke if both of their parents smoke? Okay, so let's go back to the table. We want to look at students that do not smoke and having both parents that smoke. Students that do not smoke, so that would be this row, and both of their parents do smoke. So both of their parents smoke. So we're looking for the overlap between them, which happens right here. So we're going to do 1380 over 5375. And it asks us as a probability, so we can just leave it as a fraction. If it asks us to round to something, then we would divide and then round. Okay, part C says which is more likely? A student does not smoke if neither of their parents smokes, or a student smokes if both of their parents smoke. Okay, so we need to go back to the table, and we have two separate probabilities to calculate. So first we'll deal with just the first one. A student does not smoke if neither parent smoke. Okay, so student doesn't smoke, so that's this column, and neither of their parents smoke, so that is this row. So here's where they would intersect. So that's 1168 over 5375. And we're going to compare this to student smokes and both parents smoke. Okay, student smokes, both parents smoke, that was 400. 400 out of 5375. Well, since these have the same denominator, I don't think we really need to change them to decimals to tell which one is more likely. Obviously, 1,168 out of 5,375 is more than just 400 out of 5,375. So I guess we could say that it's more likely, according to this data, that a student does not smoke. That a student does not smoke if both parents do not smoke. Okay, now we're going to turn the paper over, and we're going to look at the second example. Okay, so in the second example, This is on how to fill in our own two-way table. So we're going to fill in our own two-way table, and then we're going to answer some questions about it. So first thing we need to do is read the question. So I want you to pause the video, read the question for yourself, and underline anything that you think is important. Okay, I'm going to read it now so that we can dissect the information together. Obedience Schools for Dogs is a small franchise that offers obedience classes for dogs. Some people think that larger dogs are easier to train and therefore should not be charged as much for the class. So they have this idea that larger dogs are going to be easier to train. To investigate this claim, dogs enrolled in the classes were classified as large if they're 30 pounds or more, or small if they're under 30 pounds. The dogs were also classified by whether or not they passed the obedience class offered by the franchise. 45%, okay, so now I'm seeing numbers, so I'm assuming this is going to be important. 45% of the dogs involved in the classes were large. Okay, 60% of the dogs passed the class. Records indicate 40% of the dogs in the classes were small and passed. So that is 2 conditions that they need. Okay, so the first thing we're going to do is, this is called a hypothetical two-way table, and it's called the 100 two-way table, because all of these numbers are out of percentages. So if we don't know how many dogs there are in total, then the percentages don't really mean much. So what we're going to do is, to give it some context, is we're going to put a 100 in the bottom right corner. And now everything will be based off of 100. Okay, so let's fill in the information that we have. 45% of the dogs were large. 45% large. 60% passed. And then 40% were both small and passed. Okay, well, first of all, 45% of 100 is just 45. 60% of 100 is just 60, and 40% of 100 is just 40. So easy conversion, we can just write the numbers when we fill in the table. Okay, 45% are large, so that means there's 40 large dogs. So I'm going to look in the row that says large dogs, and where it says total, I'm going to put 45. Then it says 60% of dogs passed, so that means 60 dogs passed. So I'm going to go to the column that says passed the course, I'm going to put a 60 down there. And then it says 40% were small and passed. So I'm going to find where small and passed the course meet, and I'm going to put a 40 there. Okay, this is all the information I was given. From this information, we are going to fill in the rest of the boxes in the table by just adding and subtracting, basically. So if I know that there has to be 60 dogs that pass the course, I'm looking in this column right here, and 40 were small, that means 20 have to be large. What else can I fill in? If there's a total of 45 large dogs, and 20 of them passed the class, that would mean 25 did not pass the class. If there are, what else? Okay, if this says 45 and this is 100, the total has to add to 100, so this must be 55. Okay, so if there's a total of 55 small dogs, then, and 40 of them pass the class, that means 15 did not pass the class. Okay, and the last thing is the total for did not pass the class, 25 and 15 together gives us 40. Okay, so I was just able to fill out this whole two-way table using the given information and filling in the rest of it myself. Okay, so now what we're going to do is look at some of those problems that are listed below. Okay, I'm just going to quickly fill in this table and take a look at the first problem. So it says to estimate the probability that a dog selected at random from those enrolled in the classes passed the class. So I'm going to look at all the dogs that passed the class, and I'm looking at the column, first column that says pass the course, and that's 60, so 60 out of 100. And that can be reduced to 3 over 5. If it can be reduced, why not reduce it? Okay, part C. A dog was randomly selected from the dogs that completed the class. If the selected dog was a large dog, what's the probability this dog passed the course. So if the selected dog was a large dog. Okay, so I'm going to look at well, it says that there are 20 dogs that are large and pass the class. So the probability of it actually happening goes on top. And then out of all large dogs. So the total large dogs would be 45. So this is approximately 0.44, but it didn't say that we had to change to a decimal, so this should be fine. If you can reduce it, go for it and reduce it. Okay, part D. A dog was randomly selected from the dogs that completed the class. If the selected dog is a small dog, what's the probability that this dog passed the class? Okay, so we want to put how many small dogs passed, which is 40 on the top of the fraction. And then on the bottom, it's out of small dogs, because it said that they're definitely picking out of the small dog category. Okay, let's look at part E of this question. Part E says, do you think dog size and whether or not a dog passes the course are related? Okay, so if we look at this, if we look back to C, the number of large dogs and the probability that they pass the class was 20 out of 45, which is like 0.44, so about 44% of large dogs pass the class. Whereas for small dogs in part D, the percentage that passed the class, it was 40 out of 55, which is approximately 0.73, which as a percentage is approximately 73%. So as you can see, way more small dogs pass the class than large dogs. So we're going to write here, yes, more small dogs pass the class. And then the final question says, do you think large dogs should get a discount? So if you remember from the original question, it said that large dogs, that some people think large dogs are easier to train and therefore should not be charged as much. Well, it looks like we just proved that from this data that small dogs are actually easier to train because it's, way more small dogs were able to pass the class than large dogs. So I would say, yes, I think that large dogs should get a discount because the probability shows that small dogs are more likely to pass. Okay, I'm sure I spelled something wrong. That's okay. All right, so that's it for now. This is on two-way tables. Tomorrow our do now is going to be on two-way tables. So see if you can try this by yourself. All right, bye, guys.